Hello, geometry students. This is Mr. Fugay, and in this video, we are going to be talking about the law of cosines, an alternative to solve for missing sides and angles of an oblique triangle. If you recall from our last lesson, we talked about the law of sines, which is a very useful way to find missing sides and angles. However, the only situations in which it's going to work, so for the law of sines, the only situations that work are when we have two angles and a side, so that's ASA or AAS, and then the dreaded ambiguous case, side-side angle. So what happens when we don't have any angles at all? Take a look at this problem here from the Algebros. If you take a look at their video on law of cosines, they have a problem here where we are trying to find the step angle of a Brustosaurus. And in this situation, we have measured some various sizes here, but we want to find what this angle is going to be. And so we can't use law of sines for this. We're going to need something else. Introducing the law of cosines. Now, before I show you that formula, let me show you a little bit how it comes to life. So if we take a look here, I have taken an oblique triangle, ABC, and its opposite sides are A, C, and B, as we've done in the last lesson. And I've split it down, once again, with an altitude down here off of vertex B, creating two right triangles. Obviously, right triangles have a lot more resources, and so we're going to use that here. So the triangle on the left, we're going to call that triangle 1 for conversation's sake. And then the one on the right, we'll call it triangle 2. What I'm going to do is I'm going to write out the Pythagorean theorem. Remember, we're given three sides, so we're trying to figure out how we can create a formula to help us find an angle. So let's start with the Pythagorean theorem. In triangle 1 on the left there, this would be h squared plus b minus x squared equals c squared. And then in the second triangle, we have a Pythagorean theorem. This one's a little bit easier. It's x squared plus h squared equals a squared. Remember, the legs are squared, and they're always equal to the hypotenuse squared. Now, our goal, just like when we learned law of sines, is we're going to try to merge these together. So what I'm going to do with the first triangle one is we're going to go ahead and FOIL this out. And when that happens, we're going to get b squared minus 2bx plus x squared. And that's equal to c squared. And then once again over here, we still have our x squared plus h squared equals a squared. Now, as I mentioned, we want to try to merge these things together. And so if you look here, we have x squared plus h squared, and we know what that's equal to. Now, I'm going to go ahead and substitute this because my goal is to create an equation exclusively in terms of a's, b's, and c's. Basically, I want to get rid of all my x's. So in this situation, I can take those two things and instead write them to be equal to a squared. Now, let me go ahead and write the rest of this out. Plus b squared minus 2bx equals c squared. Well, we are so close now. We're so close of getting rid of all of the x's in this problem, except that one right there. So I'm going to use triangle 2 to come up with one more relationship we need. Since I have this angle x right here, I'm going to use the cosine ratio. So we're going to say cosine of angle C is equal to x over a. Now, why am I doing that? Well, that's because angle C is part of the oblique, and so is side length A. I didn't want to use the h, obviously, so we're going to create that equation, and if I multiply both sides by a, those cancel out. Now I have something that x is actually going to be equal to. And so we're going to substitute that in for x here, creating this formula right here, a squared plus b squared minus 2b, and then instead of writing x, we're going to write a cosine of angle C equals c squared. And this formula right here has all a's, b's, and c's, which means we have a new formula. And that is the law of cosine. So here it is down below. Now, I've moved the c squared that was on the right. I moved it over here to the left-hand side. And the reason I did this is because if you actually look at this formula, right here, this looks like the Pythagorean theorem. In fact, the Pythagorean theorem is partially connected to the law of cosine. But what I want to basically mention here is that the hypotenuse doesn't have to be the last term or the one that it's equal to. All that has to happen is whatever side length you're going to put by itself must also be the angle, the opposite angle that we find. So notice c squared and c. Notice b squared and b and a squared and a. So even though we have three formulas, all three formulas have the same types of patterns. For example, a and b, you see a and b listed there. A and c listed here, and b and c listed here. So rather than think of it as three separate formulas, it's actually two formulas that three formulas that have a common connection between their side lengths and their angles. Now, the two situations this is going to help with is side, angle, side, and then the one that we're going to address right now, side, side, side. So we're going to go back to the dinosaur problem, and we're going to look at this, and we're going to use the law of cosines to help us find our answer. Definitely going to be useful to have a calculator here for this because there are going to be a lot of big numbers and a lot of big calculations. But that's going to go smoother if you have a calculator with you. So let's set up that problem from the previous page. And so we had side lengths of 155, 197, and 316. And the angle that they wanted us to find was right here, angle B. So because I want to find angle B, the formula I want to use in this case is going to be this middle one. So I'll write that out in its formula form, in its letter form. B squared equals A squared plus C squared minus 2AC cosine of B. Now we have everything we need except that B, and that's okay. That'll be our variable in this question. We know that B squared is going to be 316. We know that A squared is going to be 155 squared and C squared is 197 squared. Minus 2, A once again was 155, C was 197, and once again cosine of B we don't know. Now there's a lot going on here, okay? So let's talk about some of the algebraic steps that we're going to take. There are three calculations I'm going to put in my calculator. First, we're going to do 316 squared. That's going to give me 99,856. The next calculation I'm going to do is I'm going to take all my sum terms, my additive terms, my 155 squared and my 197 squared. And when I square them, I'm going to get 62,834. Yes, the numbers are messy here. They usually are going to be. Then the last number I'm going to do is I'm going to subtract, and then this number right here that's in front of the cosine B, we're going to multiply all those together because that's going to have to get divided out of my problem in the last step. So let's go ahead and write all that out. And I have all those numbers here. So once this is done, this is essentially a three-step problem. We're going to subtract the 62,000 number from both sides first. Remember, all of this can be done in your calculator, so don't feel like you need to actually sit here and do all of this math. 37,022, and now I have minus 61,000 times cosine B, and that times is important because to get rid of it, we're going to actually have to divide it out of the problem. And so when I divide it out of the problem like so, we're going to get cosine of B equals, and then this is going to give me a decimal value. At least write it to 3 decimal places or use the stored value in your calculator. At this point, we will go ahead and use our inverse cosine button. We will put in the ratio. Yes, it's going to be a negative value, and we need to do that because it's actually going to give me an obtuse angle here, and that obtuse angle is 127.3. We do not need to get a second answer. Even though cosine is negative in quadrant 3, angles in quadrant 3 measure between 180 and 270, and a triangle cannot have an angle between 180 and 270. So here, the good news is, while the algebra is a little sloppy, there's no ambiguous case. No ambiguous case. So don't cheer too loud when you hear that. Our answer here is 127.3. In fact, if you have a negative ratio, that's going to give you an angle that's in quadrant 2. A positive ratio is going to give you an angle that's in quadrant 1. Now, before you go ahead and we're going to try one of these out, there is one note I want to mention. So we mentioned about how we don't want to deal with the ambiguous case. So in order for us not to deal with the ambiguous case, we do have to be careful in the order of which we do a problem. So for this, it says for side, 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 always find the largest angle first. The reason why this happens is by finding the obtuse angle, we will not put ourselves in a situation, especially if we want to use the law of sines to help us find the other parts of a triangle. Let's talk about what I mean by that. So if we have a triangle here, ABC, and now we're going to have all three sides, I want to find all three angles. So if we set this problem up, ABC, side A, side B, side C. If we fill in all of our information, we're going to get that, we're going to get 46, and we're going to get 24. Now the largest side of this shape is the 46, or side B. Based on what we learned earlier in the class, that means that angle B is going to be the largest angle. And so the version of law of cosines that I want to use here is b squared equals a squared plus c squared minus 2ac cosine of b. By finding angle B, we're finding the largest angle, and we will avoid running into any ambiguous case when we get to using the law of sines in a second. But I want you to take a moment right now and pause this video, and all I want you to do for me is solve and find what the measure of angle B is going to be for this triangle. And then I'll pick up and we'll go from there and finish solving this out. All right, here we go. This is the process, same thing as before. So we substituted in all the different values we found and followed through the exact same process using inverse cosine at the end to get that angle B is 106.5. Now from this point, if we went ahead and we found that largest angle, this now gives me the ability to find the other angles using law of sines, which is probably a little bit easier algebraically for us to do. So we're going to go ahead and do that to help us find, let's find angle A next. So this is going to be sine of, we'll use B over B, so 106.5 over 46 equals, and then we could do sine of A over, and then side A is 33. Now, upon solving this and doing your cross multiplying and dividing, if you've already done this a few times, you know the idea here. 33 sine 106.5 divided by 46, and that's going to equal sine of A. So we cross multiply and divide it. I did that in one step. Sine of 106.5, and we're going to get a value of 0.687. We take inverse sine for that, and so that's going to give me that angle A is actually equal to 43.4 degrees. Now, the reason why we did this and found the largest angle first is by getting an obtuse angle first, 106.5, now we got angle A is 43.4. Yes, there was a quadrant 2 answer here. 180 minus 43.4 is going to give me 136.6, but hopefully, as you notice, we cannot have two obtuse triangles in our obtuse angles, in our triangle. And so that's why we get to automatically omit that quadrant 2 answer and not have to deal with the ambiguous case. So make sure we find the largest angle first. Go ahead and pause this video now, and I want you to use the law of sines to help you find. Actually, we don't need to use the law of sines. We're not going to pause the video for this because guess what? If we have two angles, we're just going to do triangle sum theorem. 180 minus 43.4 minus 106.5, that's 30.1, and that is our checkmate. Now, here's what we're going to look at for the last problem here on the video. I want you to try example 2. Now, this one's a little different, and I'm going to draw the shape, and then we're going to talk about it, and then I'm going to have you try this problem out to wrap up this lesson. So side A is 18, side B is 34, and angle C is 42 degrees. This is a side angle side situation. And so the first thing that I would like to do in this situation is I want to find side C. This would be using the c squared formula of law of cosine. So c squared equals a squared plus b squared minus 2ab cosine of c. So you're going to plug in all the values. I want you to solve for c here as a challenge. So go ahead and do that. Pause the video if you like. I'm going to go ahead now and let's plug those things in. This is 18 squared plus 34 squared minus 2 times 18 times 34 times cosine of c, and I saved the easy problem for last because all you need to do is type this entire problem into your calculator. And when you do that, and I type that all in degree mode, we get 570.39. But then take the square root of both sides, and we're going to get c equals, take the square root of 570.39, that's going to give me 23.9. And that's our first side here, 23.9. Now, for the remaining two angles, we will be using the law of sines. So go ahead and pause this video, and let's see if you can find the other two angles. Here we go. There's your law of sines. I wanted to find angle A first. I got 30.3. Use the triangle sum theorem to get angle B, and